In this video, we're going to take a look at trigonometric substitution, and specifically an example using sine. So here we have the integral of dx divided by x squared times the square root of 25 minus x squared. And because we have a squared minus x squared form, we're going to use sine. So we're going to have x is equal to a sine theta. And remember, this 25 represents a squared. So in this case, we're going to have x is equal to 5 sine theta. And then our dx is going to be 5 cosine theta, d theta. And now when we do our substitution, we have 5 cosine theta in the numerator, d theta also. And then in the denominator, we have x squared. So we're going to have 25 sine squared theta times the square root of 25 minus x squared, or 25 minus 25 sine squared theta. And now I'm going to simplify inside the square root, so I can factor out a square root of 25, which is also a 5. So we can say 1/5 out front, coming from taking out a square root of 25. And we also have a 5 over 25, which is also a 1/5. And then we have cosine theta, d theta remaining in the numerator. And then we have sine squared theta. And then the square root. Now remember, we factored out a square root of 25. So we have 1 minus sine squared theta. And now we're going to use our identity to write 1 minus sine squared theta as cosine squared theta. So we have 1 over 25 times the integral of cosine theta d theta divided by sine squared theta times the square root of cosine squared theta. And then I'm going to want to take the square root away because we have the square root of cosine squared theta. And we also have to remember that that has to be positive in order to take the square root. So we want to state where it's positive. So I still have cosine theta d theta in the numerator. And then I have sine squared theta cosine theta. And this happens if theta is in between or including negative pi over 2 to pi over 2. And now we want to cancel our cosines. So we're left with 1 over 25 times the integral of d theta over sine squared theta. And now I want to turn 1 over sine squared theta into cosecant squared theta. So I have 1 over 25 times the integral of cosecant squared theta d theta. And now we can integrate this. So we have 1 over 25 times the integral of cosecant squared theta is negative cotangent theta plus c. And now the last thing we have to do is find what cotangent theta is. So we're going to need to make a triangle. So if we go back up to here, we have x is equal to 5 sine theta, and that can be written as x over 5 is equal to sine theta. And now we draw a triangle. If this is our theta, then sine is opposite over hypotenuse, so x over 5. And then we have the square root of 25 minus x squared here. And we would get that by solving for this side, knowing that a squared plus b squared is equal to c squared. And now we need to know what cotangent is. And cotangent is adjacent over opposite. So we have negative 1 over 25 times adjacent, which is the square root of 25 minus x squared, over opposite, which is x, plus c. And then we can rewrite that one last time as negative the square root of 25 minus x squared in the numerator divided by 25x in the denominator plus c. And that's this video on trigonometric substitution using an example of sine.